on page 2 of 4.3. We're talking about slope in this section. And on the previous page, on page 1, we were given 2 points and our goal was to find the slope. So we're continuing with a couple of those problems. If you remember from, or if you want to look back at the page right now, the instructions said to find the slope between the 2 points, and then it also said indicate if the line rises, falls, or it's horizontal or vertical. Now we've started this discussion about horizontal and vertical lines. We did a little bit in 4.1. Both in class and on the video, and then it hits it again in 4.2 when we start talking about intercepts. And we're going to hit it again now here in 4.3 because you really want to have a clear picture of the differences between a horizontal and vertical line. So what's different about these, well, I've already kind of given it away, the fact that these are going to create horizontal and vertical lines. But what do you notice that is happening with the points? And if you don't notice it yet, you'll see it in a little bit. But what do you notice? Well, if you were to start by finding the slope, in other words, we were going to start by writing out our slope formula, and before we do, we want to take just a super quick moment to identify our first point and our second point. So x1, y1, x2, y2, x1, y1. Again, order doesn't matter. In fact, I think I'll shake things up a little bit. I know I'm going to be subtracting these two coordinates. I'm just going to mix it up a little bit. I'm going to do the reverse here. I'm going to do y2 minus y1 over x2 minus x1. Okay, because it's not going to matter as long as I line up the coordinates from the same point in either the first or the second spot. And so when I put these into place here, I recopy the exact formula I'm going to be subtracting, and for me personally, this is so I don't drop negatives, for me personally, I replace the variable first with just a placeholder. So instead of the variable x or y, I know there's an empty spot that I need to fill with a number. Okay? I don't even have to worry about the subtraction or the negatives or anything like that. I've already copied the subtraction. Now my job is to just copy the numbers into place. So y2 minus y1. So y2 is going to go in this first spot. I point at y2. It is -1. I take that whole value and put it in. y1 is going to go in this next spot. I look at y1, I point to it, I take that whole value, it's -1. I don't even have to worry about, well, it's subtracting it. No, I've already copied the subtraction. Now I'm just copying the number. I'll do that part in the next step. I don't try to do too much too soon, okay? And now you may have noticed these y values are the same. Let's do the next piece. x2 minus x1. Our x2 goes in this first spot on the bottom. I point at x2, which I've labeled earlier. Only took me a couple extra seconds to label it. I pull that 3 and put it right into position. I'm subtracting, so that subtraction is already copied. I don't have to worry about it. Now I just need to copy x1 into this position, and x1 is 4. And I'm going to go ahead and come up with that value, and the value is -1 minus a -1 is going -1 plus 1, the whole thing over 3 minus 4. -1 plus 1 is 0, and then I get 3 minus 4 is -1. And really any number on the bottom of 0, any number being divided by 0, any number on the bottom of 0, any number we take where you have 0 divided by that number, your answer is going to be 0. Okay, and 0 doesn't mean no answer. That is an actual number. It is a thing. Now let's look at what just occurred here. What we have are 2 points. We have 4 -1s. 1, 2, 3, 4, -1. And then we have our second point of 3 -1. 1, 2, 3, -1. Okay, so there's our 2 points. What we have here is a horizontal line. Okay, so a horizontal line, because we can draw a line between 2 points. The slope is the movement of that line from one to another. Okay, so this is a horizontal line. A slope of a horizontal line is 0. It actually has a value. It's 0. Why is it 0 here? When you think about a horizontal line, a slope represents its rise over its run. And the rise of a horizontal line, there is no up or down. There's a 0 value there, but it has all the run in the world. You can go from any point to any point. You'll have 0 up and down movement, and you'll just be going left to right, left to right. So it's always a value of 0 when you talk about a horizontal line. So you can either memorize that a horizontal line equals 0 in terms of its slope, or you can convince yourself by either drawing it out and thinking about rise over run, or looking at 2 points on that line. Incidentally, just as a reminder, the equation for this line would be y equals -1. No matter what you pick for your x value, 4, 3, 17,000, -3/2, whatever you pick for your x value, your y value will always be -1. So this is the equation. This is what the line looks like. It's a horizontal line crossing at -1. And it has a slope of 0. So I've given it all away here that we're talking about horizontal and vertical lines. So number 6 that we did came up with a horizontal line. What do you think number 10 is going to create? Of course, it's going to create a vertical line. Let's walk through this process and see what's different. We would expect kind of exact opposites. Well, what's going to be the opposite of 0? Let's investigate that a little bit. I've already identified my 2 points. X1, Y1, and X2, Y2. I'm going to use the formula here. I'm going to write it out every time I use it until I get really, really good at it here. It's going to be Y2 minus Y1. Again, you could do Y1 minus Y2 as long as you line it up on the bottom. X2 minus X1. I write out the formula, and then I take it one step further so I don't have any mistakes. It's just not worth losing points. I'm willing to put in those couple of extra seconds here. And I put my subtraction, I put my fraction line, and now instead of the variables, I'm just giving some placeholders, just a spot to put those numbers. That way I don't have to worry about negatives or anything at this point. I just copy. Y2 is going to go in this first spot. It's a 5. Y1 is going to go in this second spot on the top. I point at it. Y1 is -4. So I'm subtracting whatever Y1 is. I'm subtracting that -4. On the bottom, our X coordinates. X2 goes in the first spot. X2, I point to it. It's 3. I put it right there. X1 goes in the last spot. I point to it. It's a 3. And now you notice, I probably should have done this here. In this case, the X coordinates are the same. Okay, when the Y values were the same, we ended up with a horizontal line. So it's not going to take much to jump to the conclusion that if the X values are the same, we're going to come up with a vertical line. Let's continue figuring out what this slope is here, though. Our slope in this case is going to be 5 minus a -4, which is going to be 5 plus 4. On the bottom, you get 3 minus 3, which turns out to be 9 over 0. So you end up with any number over 0, which is the same as a number divided by 0, and division by 0 is undefined. That's the opposite of a horizontal line slope of 0. The opposite creates a vertical line, and its a slope is undefined. The line exists. It's the slope that we cannot give a value to. And why is that? Well, as you look at the graph here, and we plot those 2 points, we've got a 3, -4. We've got a 3, +5. Let's go with our over to the right 3, down 4. That's our point 3, -4. And then we plot our point 3, +5 to the right 3 and up 5. There's our point 3, 5. And we connect those dots. We only need 2 points to create a straight line. That is a vertical line. And in terms of its slope, when you think about rise over run, there is all kinds of rise. It goes up and down continuously, but there is 0 run. There's no left or right movement. There's no left or right movement. And so this is a vertical line. It's an undefined slope. So m is undefined. There is no value that we can give to it because it would we can't divide by 0. And if you need a refresher on why we can't divide by 0, that's something we did in chapter 1. I'd be happy to go over that with you either at a spare moment in class or club hours. Okay? Or that's a great question. You can take the Multicultural Center or Student Learning Center too, or the online tutoring. It'd be great to hear a different voice on that as well. So let's recap this a little bit. If you've got a horizontal line, it's a slope value of 0. It's not no slope. It actually has a slope of 0. And the equation for that horizontal line is y equals wherever it crosses, in this case -1, because that's what your y coordinates always are. So if you have a vertical line, the slope is undefined. There is no value that we can give to slope here because you'd be dividing by 0, and that we don't have a way to be able to represent that. We can't undo division by 0, and so that becomes an undefined process. But the equation for this vertical line, if y equals a number gives you a horizontal line at that number, then a vertical line equation would be x equals wherever it crosses the x-axis, so x equals 3. And we kind of hinted at that. In every point on this line, your x is going to be 3. That's what the equation is telling you. The equation is telling you the relationship between all the x's and y's. And in this case, the x wins every time. No matter what y is, x is 3. It's not going anywhere. Very stubborn. Over here, horizontal, same thing. The y is being stubborn. The equation tells us the relationship between the two, and y always wins. So our y value is -1 no matter what your x is, and that's what creates the horizontal. Over here, x equals 3 is what creates the vertical. Okay, we will move on to the bottom of the page and look at some graphs and be able to find the slope from the graphs. Oh, I'm sorry, I did want to say one more thing. I just use this as my own kind of personal tip to remember how to find slope for a vertical and horizontal line. I think of slope in terms of skiing. Makes me think of, especially right now with the Winter Olympics in full swing. Sorry if you're seeing this video in another term, but currently I've got Olympic fever. But slope, skiing, that I correlate those two in my mind together. And when I think of skiing, there should be, you know, somewhere, some sort of downhill sort of something. Well, when you're flat, okay, it's no longer downhill skiing. This is cross country, okay? There is 0. The slope is equal to 0. Okay, it's still skiing. There's still a value you can apply to that, but it's no longer downhill. And there's uphill too, probably for skiing. I've seen it in like the biathlon and the cross country one where they actually go up, right? But that's slope, and then horizontal reminds me of cross country where it still has a slope value. It's 0. It's just flat. Well, then, if you were to draw the one that's left, which is vertical, how do you talk about slope? To me, that's no longer skiing. That's just falling. Okay, that can no longer be defined as skiing. So that's how I keep track of horizontal has a 0 slope. It's still skiing, but it's very flat. Straight up and down is no longer skiing. I can no longer associate a slope with it. It is undefined. To me, it's just falling. So, cutesy, kind of silly little wave that I use to keep track of horizontal and vertical slope. Okay, now we can move on to the bottom of the page. We'll see you there.